Student, in this video, I am going to give you about the statement of Gauss theorem and then the proof of the Gauss theorem. So postulation here, what is the statement of the Gauss theorem? According to Gauss theorem, the electric flux which is denoted by phi e through any closed surface here, what is important point? Through any closed surface is equal to 1 upon epsilon naught times the net charge q enclosed by the surface, and that is also given in integral form. Whole electric flux phi e passes through a closed surface according to this statement is equal to q upon epsilon naught, and also electric flux passes through a closed surface is already vector E dot vector dA. It means this expression is called integral form of the Gauss theorem. So according to the Gauss theorem, 2 points is very important. First, the surface should be closed, and second, net charge. And it's not matter what is the position of the charge inside the surface or what is the shape of the surface. And for the proof of this Gauss theorem, let us consider a charge plus q, suppose, situated at the point O inside any surface. Suppose this one is any surface, and by the statement of this Gauss theorem, then the total electric flux through this closed surface or passes through this closed surface is equal to 1 upon epsilon naught times the net charge enclosed by that surface here. Then how can we prove this? If phi is equal to q upon epsilon naught. Suppose this one is a surface whose area is A and charge plus q is enclosed by this surface. So to prove the Gauss theorem, let us consider a small area element on this surface. Suppose this one is a small area element dA. And now the distance of this small area element from this charge is suppose r. And as you know, the axis or the area vector, suppose this one is along this one is its area vector. Area vector means normal drawn on this small area element. And due to this charge plus q, suppose electric field at this point, suppose this point is P. This point is P, and electric field due to this charge plus q at point P is suppose along this one, and this electric field is suppose E. And theta is the angle between electric field and the area vector of this small element dA. And electric flux, the electric flux through the small area element, how can we find? D phi E is equal to vector E dot vector dA. As you know, in the previous video already I have discussed this one. So electric flux passes through this small area element which is taken on that surface is d phi E is equal to vector E dot vector dA, and also you can write this one is equal to E dA cos theta. Dear student, here theta is the angle between electric field at this point P due to this charge plus q and area vector of this small element. And as you know, this area vector is always perpendicular or normal to this surface and directed outward. And electric field due to a point charge is given by E is equal to 1 upon 4 pi epsilon naught q by r square. You know this charge plus q, its distance from this point P is r. So electric field due to this charge plus q at this point P, means at distance r, is given by 1 upon 4 pi epsilon naught q by r square. And since this charge is positive, so the electric field at this point will be goes away from it. And now you put the value of E at this point here, then d phi E, you can say here d phi E is equal to 1 upon 4 pi epsilon naught q upon r square. This one is E and dA, and this one is cos theta. And now you can say here d phi E is equal to q upon 4 pi epsilon naught. You can write here q upon 4 pi epsilon naught, and here dA cos theta upon r square. Dear student, you know dA cos theta upon r square, whole this term is the solid angle subtended by this small area element, or the solid angle subtended by this small area element at the point O. And suppose this solid angle is denoted by d omega. So this one is dA cos theta upon r square is the solid angle subtended by this small area element at the point O, and suppose that solid angle is d omega. So at place of dA cos theta upon r square, you can write d omega. So d phi E is equal to q upon 4 pi epsilon naught, and here you will get here d omega. So this one is electric flux through the small area element which is taken on the surface due to this charge plus q. Then our aim is to find the electric flux passes through entire area. For this purpose, what you will do? You will integrate. So electric flux or total electric flux through the entire surface, How can we find the total electric flux through the entire surface? Simply you will integrate it. It means d phi E is equal to whole integration q upon 4 pi epsilon naught, and here dw. And here this will shows what here? I am taking the integration for whole this closed surface. And last step is what here? Integration of d phi E. You can write here phi E. And this phi E is equal to, take 1 q upon 4 pi epsilon naught is constant term, take it out here. So q upon 4 pi epsilon naught take out, and here you will get d omega. And dear student, you know this d omega will give what here? Total solid angle subtended by this closed surface. And you know the total solid angle due to a closed surface is equal to 4 pi. So at place of this d omega, you can write here 4 pi. So finally phi E is equal to q upon 4 pi epsilon naught into 4 pi. Now this 4 pi is cancelled by 4 pi, and finally you will get here q upon epsilon naught. And you can see here total electric flux phi E through entire surface is equal to q upon epsilon naught, which is the proof of the Gauss theorem. So dear student, this is the simple proof of the Gauss theorem. So first you will go through the statement of the Gauss theorem and its derivation. And remember this, the Gauss theorem does not depend upon the shape or size of this surface or the position of the charge inside the surface. inside the surface here. Either the charge is anywhere inside this one, electric flux will come q upon epsilon naught. And if more than one charge, suppose several charges be inside the surface, then for finding the electric flux we will take the algebraic sum of all the charges, and that algebraic sum of all the charges upon epsilon naught. And in next video I will be give you the some important points regarding to this Gauss theorem. Thank you.